how to put it in there, but we figured it out. So when you put it into Desmos, again, cosine x to the fourth, like that. It's the same thing. And then it graphs at 1. So just be aware. All right. I'm going to hold off on the next one. We should know that, though, because that's circles that we've already done. Look at number 10. Number 10, they give you the formulas, so you didn't even have to remember them. And again, I apologize, I was not recording. Luckily, I didn't do anything super hard until that one. To completely cover a spherical ball, a company uses a total area of 36 square inches of material. What is the maximum volume the ball can have? So if you're covering the spherical ball, that is the surface area. Okay, so like if I take the cover off a baseball, that's the surface area. Got it? Does everybody understand that? All right, so this is surface area 4 pi r. It said that is 36 inches. To be able to figure out the volume, I need to figure out what r is. That's the only thing I need for the volume. The way I'm going to do that is I'm going to use the surface area formula. Okay, so I'm going to start with the surface area 4 pi r squared equal to 36. Now, what I am going to do is leave it in terms of pi. I'm not. We're just going to do decimals. We're going to do decimals. It's all calculators, so we're good. So we're going to divide by 4 pi. So in my calculator, I'm going to do 36. I'm going to go ahead and do alpha y equals so I can make sure I get it looking exactly right. Divided by 4 pi, and it's going to give me a nasty decimal, and that's okay. I would go 4 or more decimal places, and you don't have to round if you go 4 or more. And then I'm going to take the square root, and in my calculator, I just use the decimal that's in there. And I get 1.6926. I'm going to take that r, and I'm going to put it into my volume formula. And then I'm just going to do that in my calculator. So 4/3 pi 1.6926 to the third. And I'm going to get 20.3119. I'm not a rounder, so we're good with that. All these are in terms of pi, but that's okay, because again, you get to use your calculator. We're just going to plug in our answers and see which one gives us the same decimal. It takes 2 seconds. It's not a big deal. So we're looking for about 20.3. So 27 pi is 84, so we know it's not that one. 36 square root pi is 63.8, so we know it's not that one. 36 divided by the square root of pi, there's 20.31, which is exactly what we had. And then 27 over pi is way too small, so our answer has to be C. So use 1 to get the other. And typically, I've always seen them give that. Now, again, I haven't seen the EOC, so I'm not sure. All right, we're going to keep going. Number 12 is really easy. All my stuff keeps getting in the way. A reporter wants to know what percentage of voters in the state who support building a new highway. What is the reporter's population? So the population is who do they want to survey? So again, a reporter wants to know the percentage of voters in the state who support building a new highway. Do we do the number of people who live in the state? The people who are interviewed in the state? All voters over 25 years old in the state, or all eligible voters in the state? Which one would be his population? Gotta be. You don't want to use C because then you're missing 18 to 25. You don't want to do interviewed because you have no idea who they are. And then the people, the number of people who live in the state, we don't care about what babies think about the highways because they don't drive on them. Does that make sense? Is that very good? All right. We'll talk about 13. Those are not hard at all. All right, look at one like this. This one, because it's all sine and cosine, I would rather do in my regular calculator because I can do all this easier than I can put it in Desmos, but that's just me. If you want to put it in Desmos, you can. So I'm going to go in Y1 and Y2 and put this in. All right, so carefully, I'm going to do alpha y equals, but then I'm going to do it again so that I can get my sine over cosine. So sine x over cosine x. Oh, sorry. And then we have plus, I'm going to do alpha y equals again. Cosine x over, get it right, sine x. And on the bottom, I'm also going to have a fraction, 1 over sine x. Okay. I'm pretty lazy and I don't want to type in A and D, so I'm going to try B. So sine x, let's see if it works. I'm going to zoom 6 to make sure my calculator's right. Remember, it'll graph in different colors. They will take forever. Okay, they'll take forever. These are actually tangent or cotangent graphs because they're U-shaped like this. Sine and cosine are like waves. So they just keep going waves. Anything like this is going to take forever to graph. And then, like I just told you, sine and cosine are just waves. So I put in sine. So is it going to be the same graph? No, but we still got to wait on it. So it's either going to be A or D. And again, I could show you how to do this by hand, but you're not going to like it. So just calculator, and then when you get to pre-calc, you're going to do a bunch of these, okay? Almost. There's your sine curve. Your cosine is pretty much the same way. It just doesn't cross at the origin. It looks almost identical, okay? I'm not going to do it because then it's going to have to draw that over again. So then let's try 1 over cosine, and then we know that if this doesn't work, it has to be the other one, okay? So we're going to graph. It's going to take forever again. And I apologize. Desmos may not take that long, but it would be a struggle for me to put the top thing in Desmos, like the actual question. So I know if it's a struggle for me, it might be a struggle for you. I don't know. Y'all might be smarter than me when putting it in there. Take a break, stretch a little bit, grab a drink. Almost. Sorry, y'all. Almost. Oh. One more. There we go. What'd you see? How you see it happening? You see the color changing? You guys see the color changing? So we know that that's our answer. So thankfully, we won't have to watch anything else. Okay. So again, I would just put them in your calculator. So why do I not do a unit on this? I mean, you just put it in the calculator, right? So it's not worth the struggle. That's one of those things that I can wait till the end and you guys can just throw in your calculator. Now again, when you get to pre-cal, you'll be doing a lot. Did y'all have a question?
How do you make like another fraction bar under the thing, under the cosine thing?
This one right here that I made?
Yeah.
All right, so when you did your alpha y equals, I did some stuff up here. It doesn't matter. When you go down to this block, you do alpha y equals again.
All right.
Good. I'm going to go ahead and clear this one out too while I'm in here. Let's see. Keep going. Look at number 18. Again, I'm just doing kind of the easy ones first that you should already know how to do. This one I would either do on my calculator in Desmos. So if we're looking at Desmos, I'm going to do y equals, and I'm going to do the first one. So I'm going to put the top in parentheses so that I can get the right fraction in. And then I'm going to put the bottom or the second part in. 8x plus 1. Tell me if I type it in wrong. It's hard to see a little bit. 4x plus 5. And then you guys can see that it crosses right here at 2.8. but it doesn't give me 2.8 on my sheet. It gives me all kinds of numbers. But I know the first two, I'm going to go back to it so you guys can see it. It doesn't give me 2.8, but it is a positive number. So I can go ahead and mark these out. And then I can look, or I can put it in here, 14/9 gives me 1.5, so it's not that one. So let's try 14/5 gives me that 2.8. So my answer would be D. I'm going to keep going. I got 10 minutes left, but I'm going to keep going today. Okay. I'm not going to go the entire period, but I want to go a little longer than 40 minutes. Okay. Is that good? All right. Y'all just, if it runs out, just go back in. On your next one, number 19 is the exact same thing. Which function is equivalent to that? Anytime you see equals or equivalent, you can literally just type it into Desmos. I'm going to type this into Y1. So you can do completing the square if you'd like. It doesn't matter. Or you can plug it in and compare it to your answers. So if I look on Desmos, take all this out, and I plug in my first one, which was y equals x to the second minus 6x plus 10. On the second one, I'm going to put in my first answer. So A is x plus 3 to the second minus 1. Is it the same graph? Obviously, it's not. You guys see that? So A is not our answer. Your next one is x minus 3 plus 1. Is that the same graph? Did it graph over itself? Yeah, it graphs right on top of itself. And if you're not sure, you can click this little thing right here and it'll turn it off. So you can see that it goes from red to blue, just in case you weren't looking and it threw it up there. Okay, so turn it off, turn it back on, and you can see that it graphs over itself. So our answer for this one was B. All right, you can do the same thing on the next one if you like. Which expression is equivalent to that? So the divide or whatever, when x is restricted so the expressions are defined. I'm going to show you what it looks like by hand, and then we'll do it on Desmos, okay? So by hand, remember, we don't divide fractions, we flip and multiply. But at the same time, I'm going to factor them. What are your factors of negative 21 that add to 4?
7, -3.
Okay. I'm going to flip and multiply, so that means that x plus 5 is going to go on the bottom. And then on the top, what are your factors of 15 that add to 8? X plus 3 and x plus 5. Remember, if it's the same on the top and the bottom, we cross it out. We left on top an x plus 3. On the bottom, x minus 3. So your answer is A. Again, I know how to do that quickly. If I'm not very good at factoring or I can't remember what to do, you can put that into your Desmos. Again, this one gets complicated because it's a bunch of fractions, but that's why I use parentheses. I'm going to use 2 sets of parentheses this time because there's 2 fractions. So this is where I said Desmos really, really sucks on this. Okay, I don't like it. I can use my calculator to do the same thing, but I'm not going to. Divided by, I'm going to go ahead and use parentheses again, x squared, get out of that, plus 4x minus 21. Then we have another divide, so that brings the divide for the bottom. 2 sets of parentheses because I have a fraction, x plus 5 divided by x squared plus 8x plus 15, parentheses, parentheses. So there's that. And then the good thing is you can see that it's not 1 or -1, so C and D can be marked out. And then we're going to put in the other one, y equals, parenthesis on the top, x plus 3 divided by x minus 3. And you guys can see that it changed it colors. There's what it did. Okay. So can you use Desmos? Yes, it's really hard to put in those fractions. You may want to play with that a little bit this weekend. I know that sounds stupid, not this weekend, but tomorrow. Sounds kind of stupid to do, but I mean, what's it going to take you 5 seconds to learn how to do this? So make sure you know how to put those in correctly. Okay. I'm going to go back to my packet. That is the end of that one. We're gonna go back through and see what we see now. 5 minutes. Look at 15, same packet, number 15. All right, so the figure below shows concentric circles, which just means they're like ripples. They're inside of each other. That's what concentric means. All right, both are centered at O. Chord XY is tangent to the smaller circle. Remember we talked about tangent is either going to be like the ice cream cone theorem, or it's going to make a right angle. So we need to think about those two things. So it's either we're talking about ice cream cone being equal, or tangent's going to make a right angle. So the radius of the larger circle is 15. The radius of the smaller circle is 12. So watch this carefully. If you have done this multiple times, you can see it. Sometimes it's really hard. But the reason they give you this is because we're going to make a right triangle. All right. So tangent is either ice cream cone. We're not going to have any ice cream cone because it's not outside of the circles. So it has to be a right angle somewhere. So if we connect this line right here, we make a right angle. I just made the radius of the smaller circle, which was 12. I do not care which way you go from here, but I'm going to connect O to X or O to Y because that is also a radius, but it's the radius of the larger circle, which is 15. Using those two measures, we can find X to the center of the line, which is half of XY, and then we can multiply it by 2, okay? So how do we do this? X squared plus 12 squared equals 15 squared. In my calculator, because I'm lazy, I'm not even going to do the work. 15 squared minus 12 squared. Don't try to do that in your head. Just do it in your calculator. We get 81. So then X is 9. If you have to take the square root yourself, then do that. So that means this is 9. So how much is this side? 9, because they're equal. So then how long is XY?
18.
Perfect. So your answer is C. So just so you see all that at one time. Any questions? All right, let me see what else. Come back to that one. Yeah, I don't think I have any, I don't have any in here that are going to be short ones. Let's go ahead and go out and come back in, and then I'll go through the other as well. So I'm going to go ahead and stop sharing, stop recording.